I am Dr. Srinivasan from Chemistry Department, Associate Professor, IARE. So, in this video, we will see external treatment of water by ion exchange process. Okay. So, in the module, water technology module 2, the topic is external treatment by ion exchange process, or we can also say demineralization process. Demineralization process. What is external treatment of water? External treatment of water is nothing but the treatment given outside the boiler before it is used as a boiler feed water. Okay. Treatment given outside the boiler before it is used as a feed water for producing steam in boilers. It's also called softening of water. It reduces the concentration of hardness producing ions. In this case of ion exchange process, it not only removes the hardness producing ions but all the cations and anions. Okay. That's why it is also called deionization or demineralization process, because this process removes almost all ions present in hard water. Okay. This demineralization process is carried out by ion exchange resins. Okay. These are all commercially available ion exchange resins, but they are costly, but still they are available. Ion exchange resins are insoluble, long chain cross-linked organic polymers with a microporous structures. The resins are made up of copolymers of styrene and divinyl benzene. So, copolymers means they have two different monomers, divinyl benzene and styrene. So, when they combine two different monomers combine to form a polymer, we call that polymer as a copolymer. The functional group attached to the polymeric chain of resins are responsible for the ion exchange properties. Okay. Functional groups present in resins are responsible for the functional groups attached to the polymeric chains of resins are responsible for the ion exchanging properties. So, ion exchange, the word itself says, it takes the ion from water and gives the ions from resin. So, from resin to water, from water back to resin, like that. Exchange. Okay, ion exchanges are of two types based on the functional groups is used in this ion exchange process. One is cation exchange resin or cationic resins or cation exchange resins or cationic resins or cation exchangers. Okay. Anionic resin, anion exchanges or anion exchange resins. We can call anyone, all the same. So, in cation exchange resins, resins containing acid groups like COOH, SO3H, carboxylic acid, sulfonic acids are capable of exchanging their H plus ions with other cations, okay, including calcium or magnesium. Not only hardness causing salts, ions, but also other ions like K plus, Na plus, etc., etc. Anything, Fe2 plus, anything. So, any cation. This is called cation exchange resin and it is represented as RH. Okay, RH. H for H is nothing but it is exchanging the H plus ion with the water and taking the cations. So, RH, we represent this shortly by RH. So example, these are all the sulfonated coal, sulfonated polystyrenes, or COOH or SO3H, like that. Next, anion exchange resins or anionic exchanges. Okay. Resins containing basic groups OH minus, amine, NH2 minus, amido, are capable of exchanging the anions with another anions, chloride, sulfate, or nitrate. Okay, Cl minus is there already, etc. Sulfides, sulfates. Okay. The other group contains substituted amino groups such as NH2 plus OH minus NH4, different quaternary ammonium hydroxides, which OH minus are replaced in water. OH minus ions are replaced by anions in water. For example, RCH2 NME2 plus OH minus. This OH minus is responsible for exchanging anions from water, or OH, urea, formaldehyde resins, etc. Okay. These are all examples of anionic resins. So this is the structure composed of polymers of divinyl benzene and styrene. Okay, copolymers of styrene and divinyl benzene. This is a cationic exchange resins. It is basically this hydrogens, SO3 minus H plus. These hydrogens are going to get exchanged with cations from water. So it is represented as RH. This H, whatever I am writing here, this H, round circled H is represented. Remaining portions are all represented as R. Okay. The resins containing acidic functional groups like COOH, SO3H, SO3H example is shown. It's capable of exchanging their H plus ion with other cations from water. So what happens after some time, after exchanging the cations from water with H plus ions, they get fully exhausted. All H plus are occupied by cations. So we need to regenerate. You can again use this resin by regenerating the resin. Okay, regeneration of resin done by treating with HCl solution. So what happens again? H plus ion will come in the same position, and all cations will be taken out, and they are formed as like calcium chloride, salt. They get soluble, and we can remove that. So once this regeneration is done, again capable of exchanging their H plus ions with cations. Okay. Okay. So this is the cation exchange resin. Okay. Next, anion exchange resin. Here the OH minus, NME2 plus OH minus, NME2 plus OH minus, NME2 plus OH minus, NME2 plus OH. This OH minus ions are exchanging with other anions present in water. So we represent this OH. This OH is represented here, and rest of the things are R. So R OH. The resins containing quaternary ammonium or quaternary phosphonium or tertiary sulfonium groups. Okay, it's capable of exchanging their OH minus with other anions, chloride, sulfate, nitrate, different anions. Okay. Regeneration, again, once all this OH minus ions are exhausted by exchanging with anions, we can regenerate this by treating with NaOH solution. Again, OH minus will go there, and all the anions will be taken out. So that it becomes regenerated and capable of exchanging again OH ions with the other anions present in water. Okay. So this is the principle behind this ion exchange process. Okay, this is a diagrammatic schematic diagram. This is a schematic diagram of ion exchange process. Okay. So hard water first comes inside the cationic exchanger bed. Bed means it has a gravel, sand, and then the layers, we call it as bed. So that water comes into this cationic exchanger bed. Then what happens? Of course, these are all to sink. This is depends. Okay, whenever we want, we will use it. Not all the time. Okay. Okay. So what happens? Through the cation exchanger bed and then gravel, the water comes out. So the water coming out will be exchanged for cations and taken H plus ion. So the water comes out from this cation exchanger is acidic due to the acceptance of H plus from the cation exchange bed. Okay. Now again it now comes and pass through the anion exchanger bed. Again here anion exchanger bed, the water is passed through, then sand, gravel, and then comes out. So the water comes out here is called soft water. Okay, it's not only soft water. Soft water means only hardness containing ions are removed, but this is demineralized water. Okay, so here water obtained from ion exchange process, it's also a soft water, but all soft water are not deionized or demineralized water. Okay, so here this is not only a soft water, in addition to the demineralized or deionized water. So the water comes out is soft water. So here it becomes again neutral, which comes out because H plus plus OH minus gives H2O. H plus is taken here, cations are given to the cation exchanger. Here anions are given to the anionic exchanger. OH minus ion is taken by the water. So whatever the acidic water comes here, it gets neutralized because of OH minus ion presence. So H plus plus OH minus ion gives water. Okay, as we said, this cation exchanger and anion exchanger bed may become fully exhausted by already exchanging the all the H plus and OH minus ion. So there is, after some cycles, we need to regenerate for the usage of this same cation exchange and anion exchange resin beds. So normally we regenerate by acid the cationic exchanger and alkaline regenerated for anionic. Okay. So if you pass HCl, what happens? That time you will close this and opens this. Okay. Whenever we want, we close this and opens this. So all the H plus ion will come to the resin, and then the cations will go out as along with the sink. Here, similarly, we will close this, and then when we inject alkaline NaOH, then the chloride, whatever the anions will, OH minus will go to the resin, and whatever the anions it exchanged, it will come out to the sink. So thereby we are regenerating the anion exchanges and cation exchanger bed for again using it as a ion exchange. Okay. Okay, so this is the rough idea of ion exchange process. We will see more in the by equations. Process. What is the process? First, the hot water is passed through ion exchange, cationic exchanging column. It removes all the cations, including hardness causing calcium and magnesium ions, and release equal amount of H plus from the cation exchanger bed. So 2 or H, either you put H plus or H or H plus, doesn't matter. Okay, you can write it with RH also. Okay, 2 RH plus calcium 2 plus gives R2 calcium plus 2H plus. Okay. So whether here you represent as H plus or H doesn't matter. Whereas after it gets exchanged, it will come out, it will become, it release H plus to the water. Okay. That matters. Similarly, 2 RH plus Mg 2 plus gives R2 Mg plus 2H plus. Similarly, RH plus Na plus gives RNa plus H plus. RH plus K plus gives RK plus H plus. Like that. So, the water comes out of this cation bed will be acidic because of the H plus ions released by the cation exchange bed for the exchange of cations. It takes the cation and releases H plus, the cation exchange. After this, the hot water is passed through the anion exchange column, which removes all the anions like sulfate, chloride, etc., and released equal amount of OH minus ion from the column. So here also again ROH plus Cl minus gives RCl plus OH minus, or 2 ROH plus sulfate gives R2SO4 plus 2 OH minus. Okay. Like that. So, okay, next. So, the output water which comes out from the anion exchanger is called deionized or demineralized water. After several usages, the ion exchangers get exhausted. Exhausted means they are not they cannot be used anymore. It has to be regenerated before using it again for further ion exchange process. The cation exchanges are activated, or it's also called activation or regeneration, by mineral acid HCl, anion exchanges by dilute NaOH solution. So we have seen this already, but again in the form of reaction. See, R2Ca plus 2H plus, or you can write HCl itself plus HCl gives 2HCl gives 2 RH plus calcium chloride. Okay. Or Na plus HCl gives RH plus NaCl. This RH is nothing but cation exchanger. Is represented as RH. So similarly, anionic exchange bed by treating with OH minus. Okay, treating with OH minus. Okay, so once you do this regeneration, here also you see it forms ROH. Okay. 2 we'll write it as 2NaOH gives Na2SO4, 2ROH plus Na2, 2ROH plus Na2SO4. Similarly, RCl plus NaOH gives ROH plus NaCl. So this is nothing but your anionic exchange bed. Okay. So this sodium sulfate, sodium chloride, all those things will go out via zinc. Is eliminated. Okay. Okay. So this is how ion exchange process is functioning. Okay. What is advantage? What is advantage of this process? The process can be used to soften highly acidic or alkaline medium. It produces water of very low hotness, so it is very good for using it in high pressure boilers for steam generation without any problem of scales, which we have seen. What is the problem? It can occur, boiler troubles. Okay, we have seen in the last video. So if you use this ion exchanged or demineralized or deionized water in high pressure boilers, it will be very good for the steam generation. Disadvantage: equipment is costly and common chemicals required are expensive. Okay, the resin is major expensive thing. If water contains turbidity, then the output process is reduced. The turbidity must be below 10 ppm. And another thing, iron and manganese cannot be treated in this because it reduces the output process by forming stable complex with the resin. So iron and manganese cannot be treated. This is one of the disadvantage. So with this we will finish this video and we will continue in the next video the further topics in water technology. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.